Now that we have variables on both sides of the equation, we're going to start to see some unusual things happening. So I've got 3 examples for you, and something different is going to happen for each of these examples. The first one, right here, we're going to get these like terms together. So we've got the 8 and the 14. We'll subtract 8 to get those together. That gives us 6d still left on this side. 14 minus 8 is 6. And we still have this plus 3d. Let's now get the d terms together. So we want to eliminate this one completely. We're going to choose to subtract by 3d, subtract by 3d, and that gives us 3d equals 6. Finish this out by dividing, and we get d equals 2. So far everything is exactly like what we've been seeing before. We'll take a look at this one, and we're going to see something different happen on this one that we didn't have to deal with because we didn't have variables on both sides. So let's distribute this 6. We get 12y plus 6, and over here we have 12y plus 6. Get these like terms together, so I'm going to subtract 6 to get that onto the other side. 6 minus 6 is 0, and over here we have 6 minus 6, which is also 0. So we're left with 12y equals 12y. Now I'm going to come back to this in just a moment, but I'm going to do what we would normally do to get our y terms together, which is to subtract this. So we're going to eliminate this entirely from one side, which means we need to subtract 12y from the other side. 12y minus 12y is 0, so we've eliminated all the y's on that side. And 12y minus 12y is 0, so the y's are completely gone from both sides, which is the unusual thing. I see this scare a lot of my students because the variable is gone. Okay, let's talk a little bit about what this means, and I'm going to go back to this 12y plus or equals 12y. Now I'm going to pick a number to plug in for y. Let's say 2. That would give us 12 times 2 equals 12 times 2. 12 times 2 is 24, and 12 times 2 is 24, and we can see that that worked because 24 equals 24. Now, no matter what number I plug in for the y, this will happen. We'll get the same number on this side as the same number on that side because these two things are exactly the same as each other. So every single number that we put in works. That means that all real numbers are a solution. Let's go back to here, and we can see that we've got the same number on both sides. This tells us that the y never mattered in the first place because every single number that we plug in gets us something that's equal. We can see that here, and we can see that here. All right, let's take a look at the last one, and something different is going to happen with this one as well. So we've got to distribute. 5 times 1 is 5. 5 times 2m is 10m. And then 1/2 times 8 is 4. 1/2 times 20m ends up being 10m. All right, let's get our like terms together. So I'm going to subtract the 4 from this side. And we get 1 plus 10m equals 10m. Subtract that 10m, and we get 10m minus 10m, which is 0, and 10m minus 10m, which is 0 on this side. So we have eliminated all of the m's, again like we did with the last question. But on this side we have 1 plus 0, which gives us 1, and on this side we just have 0. 1 is never equal to 0. Now our goal is to be able to figure out what numbers make them equal, and there is no value that's going to work for this because there's no m's left to help us get them equal to each other. So nothing works here. There is no solution. Okay, so we've got 3 scenarios. We can see, hey, we've got one solution right here. It was just normal for us to solve. It's 2. We got that through our steps. When we had 0 equals 0, it turns out that every single number worked. So we have all real numbers. And right here we have 1 equals 0, and it clearly does not equal 0, so there is no solution. So take a look at these 3. If you ever see 2 numbers that equal each other like this, every number works. If you see 2 numbers that don't equal each other like this, then every number doesn't work. And you can kind of see that in various places. Thank you.